Hey everybody, I just want to kind of go over the integral test with you. Some of you guys had trouble with it, mainly writing it. And it's not that you had trouble with the integral, it's just rewriting it, how to write everything out. So we're going to take a look here real quick. So we got to get this series here, 1 over n squared plus 1, and we want to know if just does it converge or diverge. Now, typically for this series right here, I would use direct comparison. I think it'd be a lot easier to use. But in this case, we're going to have a little bit of fun, and we're just going to use the integral instead. So what first thing we got to do is we got to redefine this as a function. That's the first thing we're going to do. We're going to say we're going to let f of x equal this 1 over x squared plus 1. And this has to satisfy three different conditions. One, it has to be continuous. And on the domain, this is a continuous function. Continuous function. It also has to be positive. So, and this is going to always be positive. If I take a look here, it's always going to be a positive value. Even if it was a negative, we're just going to factor it out and make it positive. So, has to be positive, and the function has to be decreasing. As n gets really large, the terms get smaller and smaller, in which it does here. So and decreasing. After we establish that, then we can set up our integral. Now, when we set up our integral, we're going to go from 1 to infinity, but I already recognize this as improper, so I'm going to go ahead and set it up. This becomes 1 over x squared plus 1. And now for the part that we keep forgetting, you got to have that dx right there. You need to have this. In an integral, that's very important. We can't give you credit if you don't have that differential. When we get to multivariable, we talk a lot about the differential. It's going to mean different things for us, so we have to have that. And of course, this is just our arctangent of x. A is x, sorry, A is not x, sorry, it's u. U is x, A is 1. So this is going to give us the arctangent of just x, and that's going to go from 1 to b. Now I didn't leave myself enough space, so I'm going to move that over a little bit. This is going to go from 1 to b, and I have to get out my limit as b goes to infinity. Applying my rule, I get the limit as b goes to infinity of the arctangent of b minus the arctangent of 1. Now, I already know that the arctangent of 1 is just pi over 4. But as we let b go to infinity, well, if we let b go to infinity, this is saying where is tangent equal to infinity? In other words, where is tangent undefined? I'm looking for a vertical asymptote. Where does tangent have vertical asymptotes? And the only two options I have are negative pi over 2 and pi over 2, because that's our restrictions for tangent. So we're going to pick the pi over 2 because we want positive. And if you forgot that, look down here below. Remember, tangent looks like this between negative pi over 2 and pi over 2. It looks like this. And at pi over 2, we approach positive infinity. And at negative pi over 2, we approach negative infinity. So this is going to become pi over 2 minus pi over 4. So what I don't know exactly what that equals necessarily, but I do know that this is a convergent number. So I can say that the integral converges. Therefore, if the integral converges, the integral test says if the integral converges, therefore we can say that the series converges by the integral test. All right, there you have it. The world famous integral test. I'll see you later. Bye bye.